Okay, so today I take the occasion of our meeting to give an idea of what we are planning to do with SlapOS in the future in terms of technical roadmap and business. So, last year I collected figures from Gartner, Forrester, IDC and those companies about the future of cloud computing market. That was before Edward Snowden. And if we were reading all the evaluations, there's a linear curve of a growing market that is expected to reach about $300 billion by 2022, with more than 50% for software as a service, infrastructure as a service that is planned to grow then decrease. That's not my invention, that's what you really get if you look at Gartner, Forrester and IDC. And something else they call dynamic cloud or platform as a service, the name varies, that is supposed to grow. But in 2013, there are a couple of things that changed. First, we learned that cloud computing is not profitable. For example, Salesforce.com lost $1 billion over 10 years. And if you take the balance, the accounting of large cloud companies in the United States when they go to stock market, you might find out that they all lose money and lose and lose and keep on losing money. There's a nice article by ZDNet that compares Salesforce.com, NetSuite, various software as a service provider, and the baseline is simple, everybody's keeping on losing money. We learned that cloud computing is not private. Well, we learn every day that it's not private, and it goes beyond the worst paranoid obsessions that one ever had. China is just 10 years in advance, and anything that has been said 10 years ago about China, well, we have it now, but in worse. We learned that cloud computing is not resilient. About 8 hours per year of downtime, 1,000 small companies losing all their data on the first server in Japan. Last December, one of the biggest e-commerce companies in Australia just got their e-commerce site down for 1 week on IBM Cloud, just before Christmas, just at the time they had to do the sales, and it collapsed. And news about collapse of cloud infrastructure keep on coming more and more. Is not resilient. And the worst now, it's expensive. This little device costs 40 euro. That's about 1 month of service of Salesforce.com. Not much more. But it can run a CRM for 10 users during 2 years. That's 180 times cheaper than Salesforce.com. So, if this does same nowadays thanks to free and open source software, as what software as a service does, 400 times cheaper than cloud computing and software as a service, in a free market, there's no reason that there's any more business for cloud. So, we have 4 major disruptions in 2013 that mean that the future of cloud is not as bright as it was probably expected. So that's my personal prediction. Not 300 billion, maybe half. With a software as a service growing but stabilizing. Infrastructure as a service, same thing. So doing today cloud computing as a business is probably doing the same as personal computing 10 years ago. It will still grow, but we know nowadays the situation of personal computing. It's stable, nobody makes business, all companies are sold to whoever can try to get some profit from something that is by itself unprofitable. So what are we going to do with SlapOS in such a situation? So there are two areas where cloud has still some use. The first one is for anything where privacy and resiliency doesn't matter. You can use cloud if you don't care to lose your data and you don't care if tax office reads your data. Second case, whenever HTML5, and that's another disruption, doesn't work. So we'll show that in the next presentation. But nowadays, I can take a phone, turn the phone in airplane mode, like this. Then, once the phone goes to airplane mode, I can still go open my web browser, type the URL, and even if there's no network connectivity, I can still get some web application working with storage, queries, everything without application server. That means this application can be distributed to 1 million users only with one server like this. But this approach, of course, doesn't work if I have to process 1 petabyte of data. 1 terabyte, very soon. 1 petabyte, not yet. So that's maybe the second case where there's still something to do for cloud. So with VFib and SlapOS, we are going to focus on only 2 services. One is resilient computing. We stop calling it cloud, and we only try to focus on technologies that can guarantee resiliency. So resilient platform as a service means that we try to design the platform as a service in a way that whatever node crashes, it still works. Resilient VM is just a virtual machine that exists in 3 totally independent social contexts so that anyone can break, it still works. And automated disaster recovery, and that's actually the most important part, is to bring the same approaches as everybody does for quality assurance of programming, but to disaster recovery. The idea is to test every day that any infrastructure can be recovered from scratch. This last idea, automated disaster recovery, is, in my opinion, the only truly long-term application of SlapOS, and will probably be commercialized or in a typical open source way rather than in a service way like cloud. People will deploy by themselves the technology that guarantees that their application can automatically recover. Then on the other side, we are going to sell big data as a service for people who don't care that their data will be lost or spied. So for research, for example, doesn't care too much usually that their data is going to be spied by tax office or army. And so thanks to cooperation with Paris University and Telecom Paris Tech, we are now offering 1,000 servers plus 100 mini servers with solid state disk, 1 tera memory machine, and 2 big data stack, one based on Python called Vendelin and another based on Java called Hadoop. We don't expect to make more profit from this than any commodity business is going to do. But if one has to research 1 petabyte or 1 exabyte of data, having such a shared infrastructure makes sense. It also changes completely, especially Snowden, how SlapOS architecture is foreseen. Before the disruptions of 2013, the idea was rather to have multiple providers operated independently and cooperating to exchange part of the storage or part of data. So the user works with one provider. The provider has its own resiliency mechanism, but uses another provider to be sure that data is not lost, even if some bad person takes control of this company. That was our idea. It is mostly implemented. But the issue nowadays is this person cannot trust this infrastructure anywhere in the world. So we are moving to this approach, where this person uses this to do the same thing as what used to take this size. And if they really need to do some massive processing of data that can be lost and spied, they can outsource the processing to some commodity place, wherever it is. And in order to keep copies of data and application, they are going to ask different companies to keep a ready-to-be recovered application. So daily work works this way, and instead of cloud we have resiliency as a service and big data as a service, and both of them have some use, but majority of usage becomes here. And so the good news is that this architecture is now already implemented. And the funny news is that the protocol between here and here is the JIO protocol and API of the Resilience project. So let me show you a demo. So the demo is a client application fully written in JavaScript, only with JIO API, that can do everything that SlapOS does. And the nice part is that this application, fully written in JavaScript, has been fully tested using QUnit framework, using local storage, then connected to the backend and providing same behavior. So one single code, different backend, same behavior, same test. Let's see. So I'm going to go to our Git server. That's also the other funny part. To host such a JavaScript application, we just need a plain static HTTP server. Okay, let's start. Now I log in, so I'm sorry, I still use my Facebook login. So I connect with Facebook, and now it works. Now that I have now I'm outside China. And so I can go to menu, look at my services, then it queries the system. By JIO we get the result, and click on some place, queries, get the result. We see the result of an instance. So in this is still a prototype. But what is good is that it shows that one can make a whole application where absolutely everything is done on client side. And this is not that simple application. It's a full cloud panel system where you can go and check servers and do operations on servers, but everything is done client side. And the only API that programmer has to learn is JIO, that is get, put, host, all docs, finished. So, and what's nice is that the way we write the graphic client and the way we make SlapOS servers interoperate is the same API. You can use it. I can give you the URL. It's public. Everything is public. So we use a framework for this. That's like for everything we do nowadays. We are developing with a framework called jQuery Mobile that can be customized to appear nice. For example, if you're on mobile, the interface will be smaller, like this. Or we go to servers, and we get the list. And things are displayed in another way. So it's completely responsive. It really works. And the great thing in this way of programming is that developers who do the front end can test by themselves the front end fully autonomously from developers who are doing the back end. Because they test the front end with a local storage while developers make the back end, run their tests by themselves, then they just need to interconnect, and the whole model is just a document model. So that was our first demo. We have a second demo now. It's Big Data as a Service. So that's from Marco, he's here. Is there a way to connect to your demo, or do you want to plug? It's better to show on your laptop. So he will show this in a few minutes. And it looks like just an IDE online where you can define your own scripts to run Hadoop batches, then they are deployed on hundreds of servers. So this service has been announced officially 2 days ago in cooperation with Paris 13 University and Telecom Paris. It's fully open source. Anybody who wants to create his own big data as a service platform can just do it with SlapOS. It's there. It does the deployment, the billing, the IDE, everything. Nothing to reinvent. Our direction for big data is to develop something called Vendelin. It's a technology where data analytics are implemented using a library called scikit-learn. It's a library created at Telecom Paris Tech that has the best algorithms for classification and prediction. But this library is limited to the amount of memory of each server. And what we'd like to do is make this library handle data models that go beyond the RAM memory of a single machine. So if we change a bit of code in scikit-learn, not so much, then rely on another library called Neo, that is a distributed Python object storage. We can aggregate memory from different machines as if it was a single machine, and handle classification models that go beyond RAM. Nobody is able to do that except maybe SAS Institute. And if we can handle models that are, for example, terabyte models or 10 terabyte models, that means we can go towards handling data sets that can reach exabytes. And because it's big data, and because a phone will soon be a terabyte, but it is not so soon before a phone can handle 1 million terabytes, that is an exabyte, then there will be a kind of need and thus a market in this direction. Then the demo 3 will be presented in the next presentation, and it's about personal cloud and how we can run a personal cloud with SlapOS that can then offload resiliency to commercial services. So now Marco will make the demo. I have no idea if there is a new machine. Display.
Okay, so we are not using the SlapOS interface when we are connected to the node. Anyway, this instance has been built with a built-out recipe like all the other SlapOS software releases. So I am inside the web runner, and here is the final build-out for the instance. There are a couple of demos. The first one requires very little data, the second a bit more because it's a full dump of Wikipedia. It's a bit more interesting because Wikipedia dumps come in huge XML files, and so they have to be treated with streaming XML parser, so they are quite time-consuming and memory-consuming. So we are doing the easy, the fast demo here. This is using the streaming Hadoop protocol, the easiest one, the fastest one to implement. It doesn't require Java. Any language can be used, Python, everything else, because it basically works with standard input, standard output. There is a mapper process, the reducer process, and the work is automatically split by Hadoop, and we have a single output at the end. So there is a script to download some books from the Gutenberg projects. There is a script to load files inside the Hadoop file system. The very simple mapper. This is simply doing split and count of the words inside the books without even tokenization that would require natural language toolkit. This is a more bigger project. And the final script to provide us a single output. And the script to run them all use this plugin with this mapper, this reducer. The input is in this directory, and the output is there. So var Gutenberg input. Here are our books that we already downloaded, and the output is the output directory doesn't exist anymore. It doesn't exist yet. So demo Gutenberg. Run the process. This is running in the laptop as a simple node, but it depends on the configuration. It could be running anywhere. And the output. And this is the output file. Basically, the result of the distributed computation.
Is there a web runner to show this interface?
I had no time to prepare it before coming here. I'll do that.
Okay. So the Marco has shown the deployment of Hadoop in a SlapOS container. A SlapOS container looks like a shell with command lines. Well, of course, it's just directories with some commands. What means here big data as a service or Hadoop as a service means that we describe with a kind of recipe how to rebuild exactly the same experiment based on the same Hadoop libraries on any environment. So if people provide Debian distributions or SUSE distribution or Red Hat, that run either using bare metal servers or run on virtual machines using Intel or ARM processors, the same recipe can be deployed in the same way on every different environment. Then every environment can contribute to the same result. So what means here big data as a service is automation of build, configure, run, monitor of the big data batch. So this is the end of the first presentation, and please follow the next one about Demo 3, that is about personal cloud and self-orchestrated HTML5. Thank you.